This is Algebra 2 with Trig, section 13.5. We're working on applying the law of sines. Law of sines is a process where we can solve for the missing sides and angles of any type of triangle. It can be a right triangle, it can be a non-right triangle. You use law of sines whenever the information that you're given is two angles and the non-included side, or two angles and the included side. There's also a scenario where we can work with two sides and the non-included angle, side-side angle. That's the situation that's going to have to check for multiple number of triangles. Otherwise, these two will only have one type of triangle would be possible. So the formula for law of sines is the side of A over the sine of A, the side of B over the sine of B, angle B, and side C over the sine of angle C. When you're developing what sides and angle letters to be using, you've got to remember that the angle A has side A across from it. Angle B has side B across from it. Very important to set up your triangle in that same format so we all understand where side A should be located, where side B should be located. So for the first question that we'll look at, we would draw a picture for a triangle. And I'm specifically going to draw one with an obtuse angle, because we see that the measure of angle C is 100. Then the other two angles are A and B. It doesn't matter which you call which. Angle B will be the 34. And for the moment, we don't know what the measurement of angle A is. We also are supposed to know that the side B is 8. Now, for us to know where side B is, we have to identify angle B and go across from that. So side B is 8. Side C is unknown, and side A is unknown. So we have three things to solve for: angle A, and side C. So, knowing that we have two angles and a side, called angle, angle, side, we're going to use law of sines for this. The information that we know for sure is B. We have the angle and we have its side. So we're going to use B over sine of B. And since we have angle C, we're going to solve for side C. We're going to use the letters side C over sine of C. Plug in your numbers. 8 over the sine of 34 equals your unknown over the sine of 100. To solve this, we would cross multiply, and that would be 8 times the sine of 100 divided by, there would be no reason to multiply across over to C, since we have to get to C by itself. We'd divide it right back. So we'll just keep the sine of 34 over here. That's the value of C. And when we use our calculator, you want to be sure your calculator is in degree mode. So by hitting mode, you'll see that degree is highlighted. Very important. So we're going to say 8 times the sine of 100 divided by the sine of 34. And we get 14.088, so 14.09. So C equals 14.09. So that's our value of side C. So you could write that up, and we should circle the answer that you have calculated. Now, looking at the other parts that we don't know yet. We don't know side A, and we don't know angle A. Well, since we know two sides, actually, since we know two angles of this triangle, we can calculate the third angle by taking 180, subtracting the 100 to get 80, then take that 80 and subtract the 34 to get 46 degrees. That equals the measure of angle A. So now we have 46 degrees. Now we need to figure out the side of A. Since we're looking for the side of A, we're going to use A over the sine of A. Then you want to use one of the fractions that you have both the top and the bottom information for, and that would most obviously be B. That's what the given has given you already. So B over the sine of B. We don't know side A. The angle is 46. Side B is 8. And its angle is 34. To get the A by itself, we'll cross multiply. So you get 8 times the sine of 46 divided by the sine of 34. And using our calculator, you'll figure out that that's 10.29. So you can come over, label that on your picture, and be sure to circle the ones that you found. Now you know all three sides and all three angles. For our next picture, we see that we have two angles. Because they're adding up to over 90, it's 95, since they're adding up to more than 90, we know that this is going to be a acute triangle. You can label the sides, or the angles, any way you wish. Angle A is supposed to be 51. Angle B is 44. And angle C is what we don't know at this moment. We know side C, which is across from angle C, that is 11. So side A is unknown, and side B is unknown. Notice the information is two angles and the included side. So this would be considered angle side angle. Now, if you look at it from here, we don't know two bits of information from the same letter. We don't know the side A to match with the angle 51 or side B to match with angle 44. We know side C, but we don't have the angle at the moment. So to calculate for the angle, we say 180 minus the 51 gives us 129. Minus the 44 gives us the 85. So that equals the measurement of angle C. So we could put 85 up there for the angle. Now, we notice that we have side C and angle C. So we're definitely going to use the ratio with the C's. Now we've got to decide which letter we want to solve for. Well, you can solve for either one of them. It wouldn't matter. Let's solve for side A. So side C was 11 over the sine of 85 equals side A, which is our unknown, over sine of 51. To calculate the value of side A, we get A by itself, and using your calculator, we would say 11 times the sine of 51 divided by the sine of 85. And that would give us 8.58. So that's the second piece that we've solved for. Now we'll look for a final part. That's side B. That's what we don't know. So we definitely know we're going to use the fraction with the B's. Since we have both integers for C, we're going to use the fraction with the C's. I'd suggest not to use a rounded number. You always want to use as accurate as a value as you can. So side B we don't know. Sine of 44, 11 over the sine of 85. We'll cross multiply to get B by itself. And when we use our calculator, we'll find out that that's 7.67. So we can come up to our picture. I'll move this B over a little bit. So B is going to equal 7.67. And we should circle that to show that we calculated that amount. That gave us all three sides and all three angles. That was the law of sines. It is possible that you would have to solve for an angle using law of sines. So you would want to get, for example, sine of A by itself. If you got sine of A all by itself, then you would need to do sine inverse to figure out the actual angle. We'll practice that on a future lesson. Here, we're going to calculate what the area is. Notice the information they're giving us here are two sides and the included angle. That would be two S's and the angle that's in between them. If you're given that information, then we can use these formulas to calculate what the area of the triangle is. You're used to the area of the triangle being half a base times height. So if you look at each of these, the area is half a value times, in this case, C sine of A, or a value which would stand for the base, C sine of B. Now if we look at this first one, B is going to be our base. C is this side. We're going to look for the height. So if you're looking for that height, we know that we'd have the A, we'd have side C, we'd have the height of the triangle. We don't have angle C, because that would happen farther out. So to calculate what this height was, you would use sine of angle A equals opposite, which is the H, over the hypotenuse, which is C. You would cross multiply to figure out that C times the sine of A equals H. So to know H, you need to know the C value and the sine of A. So that's what they're suggesting here. To know the height of the triangle, C sine of A times the base. Base times height, take half of that. Half of base times height. So it's the same formula you've always used. We're just going about it a little bit differently. We're going to have a garden, a triangular flower garden. We have 11 feet on one side, 62 degrees, and 15 feet on the other side. We'll connect those two so we can make a triangle. We're going to use area equals half the base times the height. So we're using our formula here, half of BC times sine of A. That would help us calculate the height of our triangle. So the area equals half. Now for us to figure out what the A, B's, and C's are, A has to be our angle. So we'll put the A there. B and C don't really matter which you call which. We'll call B, and then C can be that angle at the top. So side B and side C. It wouldn't change the answer if you switched B and C around. Side B is 15. Side C is 11. And the side of angle A is 62. So using our calculator, we'll say half of 15 times 11 times the sine of 62. Comes out to 72/84. So the area is 72/84 feet squared. So on the back side, we're looking at example 6. We'll stop after example 6. We'll proceed on in a different lesson looking for the ambiguous case. But a piece of land is bordered by 3 roads. Find the area of the land. So we have this road that's stretched for 2.3 miles. We have the angle that's between the 2 roads, and we also have another side which is 1.4 miles. So if you look at this, we have side, angle, side. That's the requirement that we need so that we can use our formula. We're going to figure out the area by using half side A times side B times the sine of our angle, which would be C. Side A is 1.4. Side B is 2.3. And our angle is 78.84. 1.1. So we can plug that into our calculator, and when we do that, we'll come up with an area of 1.58, and these are miles squared. So that's using a new area formula. You can use this area formula anytime you have two sides and the included angle.